Hey guys, I hope everything is well. Today I'm going to show you how to implement multiple regression in Excel. And I'm going to use a data set from the American Housing Survey, which has a lot of detailed information about houses in the United States. We are going to use market value right here as the dependent variable. So actually, this is going to be motivated by that same research question, kind of like house price, the determinants of house price. And we have three independent variables that we're going to take a look at: bedrooms, size, and bathrooms. So bedrooms, that's just the number of bedrooms. Bathrooms is just the number of bathrooms. Size, however, it would be really nice if this is in square feet, but unfortunately the American Housing Survey only provides this data as categories. 9 right here is the biggest category, and 1 is the smallest category. So that's just categories of how big or what size houses are. So we just have to remember 9 is really big, 1 is relatively small. All of the other numbers are just kind of ranking house size in between there. It would be nice to have square feet because we'd get more granular results and it's easier to interpret. But this is what we have to work with, so that's what we'll go with. Now, this is a pretty big data set. It has more than 10,000 individual houses. It's currently sorted by market value, so from highest to smallest. So the most expensive house in our data set is worth about $820,680 right there. And so let's start with a simple linear regression by doing data analysis, regression. This stuff is preloaded from before, but what it will look like when you start and open it up for the first time in Excel, if you haven't done something recently with it, will be like this. And so first we're going to load in our dependent variable, which is market value right here. I'll click on the title, Shift Command down or Shift Control down if you're on a Windows machine. Then we'll click on our independent variable range. I'm just going to start off by doing the simple regression with bedrooms as our one independent variable. This is something you will have to do on the draft for your final project, because one of the things you'll see in the final project guidelines is adding statistical significance. Some of you have already done this, but if you haven't, you need to do this because doing it the scatter plot way does not provide you with a p-value. And so we'll take a look at that in a second. I included labels, so I need to click on labels right there, and I encourage you to always do that. That will become increasingly valuable as we get into multiple regression, as you'll see in a second. I'm going to change this to output range, and what I like to do is to stack my results from kind of the most simple regression and then building regressions with more independent variables as we go down, because that's how we can see how our results are changing as we add more independent variables. So I will click OK. I'm going to click there and just double click between any two columns so it'll spread out and show us everything. And now let's look at, I always kind of want you to look at the 3 most important things in a particular order. I think is the easiest way to go. The thing we care about most is the slope estimate on our individual independent variable in this case. So let's start by interpreting this guy. What this means is that when number of bedrooms increases by 1, market value increases by $57,141 on average in my data. So that's a huge number. Adding 1 bedroom increases it by $57,000 basically. Now that's probably too big, as we'll see in a second, but in this simple regression, that's what our results say. Now the next thing I want you to do is consider the statistical significance of this result. Remember, our null hypothesis is that there is no relationship. So our alternative hypothesis is that there is a relationship between these two numbers. One way to decide is to use the p-value approach and compare our p-value to those 3 standard levels of significance, 1%, 5%, or 10%. This particular p-value right here is extremely tiny. This isn't scientific notation, but what this number is a decimal point with 225 zeros after it before we get to the number that starts at 226 after the decimal point. So it's a decimal point, 225 zeros, and then 11684 is what that number is. That is extremely small, basically zero. So that means we reject our null hypothesis, that there is no relationship, and we accept the alternative that there is one. And another way that's probably more common to say that is to say, this slope estimate is statistically significant. It has a p-value that's less than 0.1%, for example. You don't want to write a number that's that tiny, so you can just say something like the p-value is less than 0.1%. Just to make it clear that you have a very small p-value if something like this happens. Now, the third thing we want to take a look at is the r-squared value right here. It's easier to interpret this as a percentage, so let's move the decimal point over a couple places. And we'll just round it to 2 decimals. So remember, this number means that variation in bedrooms explains 9.26% of the variation in market value in our data set. So as you learned from the quiz, and hopefully before the quiz on the practice quiz, is that means that about 90% of the variation in a market value is not explained by bedrooms. So that means let's keep going. Let's see if we can explain more of that variation by adding more independent variables. So let's go for it. So now we're going to run our first multiple regression using the data analysis tool pack. So I go to the same place. My dependent variable market value is the same, so I don't have to change that at all. I'll drop this right here. And what data analysis toolpack allows us to do is it allows us to highlight more than one column at a time. So now I'm highlighting bedrooms and size, shift command down arrow to highlight all of the data. We have labels. We're going to put this right below our last results. So I'll just go ahead and click right there. And now this is going to stack these results right below our previous ones. Now, one thing I want to mention, so we highlighted these 2 columns. When you did your scatter plot, you wanted your independent variable on the left and your dependent variable on the right. Well, when we're starting to do multiple regression, the easiest thing I think to do is put your dependent variable in the leftmost column and then start building your set of independent variables to the right. Because you have to, when you highlight these multiple columns, they need to be next to each other. You can't like skip around. So that's why I've organized the data set this way, and your life will be a lot easier moving forward if you do that too. I would just make a new tab in your data set down here, have the first one called scatter plot, and then add a new one where you're going to do your multiple regression analysis. So we included labels. We're going to stack it right below. We're ready to push OK. So we're going to kind of go through and look in the same order, but now notice we have 2 independent variables. This is why I was saying it gets more valuable to include labels, because now we know exactly which variable each slope estimate is associated with. So let's highlight those. Now we have 2 slope estimates, right? And so those are the first things we want to interpret. Those are the things that we were really trying to estimate when we ran this regression. And we have to make a slight revision to the way we interpret once we're doing multiple regression. So now I got a different number because now I'm controlling for house size on bedrooms. So the way we'd interpret this slope is to say when number of bedrooms increases by 1, market value increases by $12,818 on average in my data holding size constant. So that's the new thing we have to add. We have to say holding size constant at the end, because now I've controlled for house size. And controlling for house size is what's making me get such a different slope estimate. Up here we got a huge slope estimate, almost $60,000. Here it dropped all the way to about $13,000. The reason that this happened is when I didn't control for size. What's true about mansions? Mansions tend to be big, or they happen to have a large size usually, by definition, and they also usually have a lot of bedrooms. So when I only included bedrooms, and I did not include an important variable that was correlated with bedrooms, size, I picked up the effective size in my bedroom's slope. So that's called, when you don't do that, when you don't include important independent variables, you get what's called omitted variable bias. You get a biased estimate of the effect. But now that we've controlled for size, we see that bedrooms on their own are not what's driving the value so high. It's size that's having a bigger impact. So remember, our size is in these categories. So remembering that, we have to recall that when we interpret our slope. So when home size category increases by 1, market value increases by $40,347 on average in my data. Holding number of bedrooms constant, because you always have to say holding the other variable constant if you have two variables, for example. Here is how we can determine if those are statistically significant. Now, this number is 0. So that's what that is saying, is that the p-value on size is so small, the relationship is so significant, that Excel has chosen to just round the number to 0. Now we know that that's insanely small, because remember up here, Excel showed us a number that was a decimal point with 225 zeros after it. It showed us that number. But whatever this p-value is so tiny that it's like, I'm just putting a 0 right there. So we know that's extremely tiny if it's showing us this number, but choosing to round this p-value to 0. It's probably got 1,000 zeros after the decimal point. Now our bedrooms number, even the slope estimate became smaller. It's still very statistically significant. So the effect of bedrooms on market value is still positive and significant even after holding size constant. This is a decimal point with 10 zeros after it before we get to a number. So that one we can even say, it's going to take a second, 0.0000000000379,082. That's what that number is if you wrote it out. I would still encourage you not to write it out, because your reader doesn't need to see that huge, tiny number. Huge, tiny number? Okay, don't think about that too hard. But, so I encourage you, if you get tiny p-values, just say something like this. So I think the best way, interpret the slope in one sentence. Next sentence. This slope estimate is also statistically significant with a p-value less than 0.1%. Now, if you get a p-value that's like 2.5%, then you can go ahead and just say it, because you don't have to write a huge, tiny number in that case. Now, a new statistic we're going to be looking at, actually, let's jump to this one first, because we can compare our R-squareds, and we know these ones already. Let's write it as a percentage, 21.78%. And now we can compare these. First, we'll just interpret this one alone. 21.7% of the variation in market value can be explained by variation in bedrooms and size in this data. So in this case, we have two independent variables. Sometimes you'll have like 20, possibly. You wouldn't want to say 21.78% of the variation in my dependent variable can be explained by yada, 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 and list 20 variables. So another way to always say this is something like 21.78% of the variation in market value can be explained by my regression model or by my set of independent variables. So you don't always have to list everyone. I'd encourage you to do it if you have 2 or 3. But once you get above that, you might want to just say my set of independent variables or my model. Now let's take a look at F real quick, because this is something that's really becomes more important when we're doing multiple regression. Now let's take a look at it up here. You'll notice that you don't have to worry too much about the F statistic. That's very similar to like a T statistic. It comes from a special distribution. The important thing is that once we have an F statistic, we can calculate probabilities. Now in our simple linear regression, our p-value on bedrooms and our significance f-value are exactly the same number. The reason for this is that significance f tells us the overall significance of the model. Well, this model only includes one independent variable. The significance of that one independent variable is the same thing as the significance of the overall model. But now when we move down here, we see that our p-values, although it's rounding both of them to 0, so this isn't the greatest example for comparison, this number and this number are not the same, it's just rounding them both to 0. But what this significance f means, this is the p-value on the overall fit of the model. It's kind of asking, are any of my independent variables significant? Now let's take a look at the book real quick, and it explains this. So we see that this is the type of model we're doing right here. This is a multiple regression because it has many x's in it, more than one independent variable. The hypothesis test for the F test, the null is that every single slope estimate is equal to 0. The alternative, the opposite of that, is at least one or more of the parameters, slopes, is not equal to 0. Notice that the intercept is not included, it's just the slope estimates. So that's the difference between an F test and a T test. An F test, we are jointly testing the significance of all of our independent variables, whereas T tests with T statistics, we're looking at variables individually. Okay? If any of these are significant, then this is also likely to be significant. So now let's take a look at what happens when we add, oh yeah, one thing that I wanted to mention on the R squared though, is that now that we have 2, we can start comparing across models. We can start saying, well, how much more of the variation can we explain now that we added this new independent variable size? Well, we were able to explain 12.52% more of the variation because our R squared jumped from 9.26% to 21.78%. Okay? So that's a good thing for you to do in your final project because you're going to start with your simple linear regression. And then one thing you need to do to get a passing grade is add at least one more independent variable. So you will have a set of results that look something like this. Now, when you organize your results, notice that there's a ton of numbers in here that we are not using. I'd strongly encourage you not to put all of these numbers that we're not using in. And you should also notice that there's some glitches in Excel. For example, look at this. Whoever coded this into Excel accidentally put the confidence interval in twice. So it's not super professional in your professional document to be like, oh yeah, I just copied the mistake from Excel and pasted it into my report. Don't do that. Watch out for that. Also, do not use chart title as the title of your chart. So now let's add our last independent variable, bathrooms, because People like going to the bathroom, so maybe having more bathrooms causes us to have higher market value. And we'll conclude all three variables this time. So let's click right here. Please go away. I don't want the details. I want you to go away. Data, data analysis, regression. So last time I wanted to show you how you highlight the two rectangles, but notice that a really quick and dirty way of doing this is that this one goes from C to D. We're going to add E. So I'm going to just go click right there, delete, change it to an E. Now I've highlighted all three of these columns because I'm going from C to E, C to E. Okay, output range, we're going to stack this below our previous results right here. Push OK. There it is. Now we have three variable names. It's becoming more and more important that we include labels because otherwise this would say something like independent variable 1, independent variable 2, independent variable 3, and that would be confusing to interpret. So by including labels, they are labeled for me. And now we can see a little bit, well, now we can see three slopes, first of all. Let's highlight those. That's the first thing we should look at. So now, when bedrooms increase by 1, home value increases by $295. Wow, that's a lot less than the $60,000 we started off with. Not only that, but that's not statistically significant anymore. Our p-value on bedrooms is no longer significant. And so, because remember, now I'm holding size and bathrooms constant. So to be clear, when number of bedrooms increases by 1, market value increases by $295 on average in my data. Holding size of home category and bathrooms constant. However, this is not a statistically significant estimate. That's crazy. Look at what we started off with again. We started off with almost $60,000 impact, insanely statistically significant. We controlled for the size of the home. Our estimate went way down. It still had a big impact, however, but it was still statistically significant as well. Now that we're controlling for size and bathrooms, we find that building more bedrooms while not building more bathrooms or increasing the size of the home. That's what that means. That would be like, hey, I'm thinking about taking my living room and building a wall in it and then making the other side of it a bedroom. That is not going to have a big impact on the home value. Because what aren't you doing? You're not increasing the size of the home by building a wall, and you're not including an extra bathroom. So if you're thinking about building your 10th bedroom in a house with 1 bathroom, that's only 1,000 square feet, think again, buddy. Well, I'm assuming you weren't thinking about doing that anyway, so that whoever I was talking to probably doesn't exist. But that's what this result tells us, right? Let's do size. Size still has a sizable impact. What? When size category increases by 1, home value increases by $30,398 on average in my data, holding number of bedrooms and number of bathrooms constant. So making your house bigger without building more bedrooms and without building more bathrooms can make your house more valuable. That makes sense. It's making a bigger house. People usually pay more for bigger houses. That is a very statistically significant slope estimate right here. Did I actually? Yep, I accidentally changed that number. So I did Control Z, highlight it because it's important. Bathrooms. Increasing the number of bathrooms by 1 increases home price by $27,230 on average in my data. Holding size of house and number of bedrooms constant. Building bathrooms adds a lot of value to homes. That is a very statistically significant estimate with a p-value that is less than 0.1%. A very low probability that we would observe this result if there was no relationship between bathrooms and market value. Significance F, now we see that it's different. Now this joint significance is 0. Our model is doing a this isn't enough to say it's doing a very good job, but it's a significant model. This set of independent variables matters to market value. Let's take a look at what we're explaining by adding bathrooms. By adding bathrooms to the analysis, 24.83%, we've increased our R squared equals this minus this. Adding bathrooms, we've been able to explain 3% more of the variation in market value than when we looked at a model with just bedrooms and size of home alone. So these are the types of comparisons you can do as you add one independent variable at a time. It gives you a lot to talk about. You can present these results in a table that you make in Word or in Excel that looks really nice. Again, I would encourage you not to just dump all of these results in your document because that will not look super professional. So this is how we implement multiple regression in Excel. We've seen that we can learn a lot. Remember, just think about what happened to this coefficient as we moved down the line. We went from huge and significant to small and insignificant once we controlled for other factors that are important. This can happen a lot in regression, and this is how we learn using regression, is by looking at different sets of independent variables and then comparing them to what we observed with subsets of those variables. Okay? Real quick, I wanted to look at the project guidelines with you. This is something you definitely want to look at before you turn in your final project. I got an impression from some people that they did not look at the project draft guidelines before they turned that in. So these top 3 things are things that you need to do to get a passing grade on the final project. You need to fix anything related to the comments I made. You could have gotten a 10 out of 10, but also missed something that was important because maybe you made up for it by doing a really good job in a different area. So make sure to look at the specific comments that I made, fix any of those, fix any problems that I pointed out. Number 2, one thing you did not have to do in the draft, but you do have to do in the final project is discuss statistical significance and the R squared. Notice that we just did that. It says, for example, comparing R squared across models. We just did that a bunch in the example that I just did. Finally, you need to add at least one additional independent variable. We added one, and then we added a second in that analysis. So these 3 things are things you need to do in order to pass the project. Now down here, you need to expand it in other ways in order to get an A or a B. This is really good stuff to ask me about when you set up your project meeting, which is worth 10% of your grade. I'm a little worried about some of the people that haven't done it yet because that's a lot of you. Make sure to do it. Make sure to not wait until the last day of class because I might say, yes, I want to do that for you, but I have project meetings with people all day today. So getting on that sooner than later is a very good idea. These are optional things. You should not try to do all of these things, but these are just suggestions for different ways you might expand your model. Many people choose number 1. Don't just add one more independent variable, add a few more independent variables, kind of like we just did in the example today. Forecasting and prediction. I will have a video about that soon. And so that allows us to forecast. So I'm trying to basically predict the future at this point using regression, which is totally sweet. And I'll have a video about that soon. Scenario analysis is very similar to forecasting and prediction, but scenario analysis is like, well, I don't really know what's going to happen, but let's look at some interesting cases. Scenario analysis would be like, what happens if you have a mansion with 10 bedrooms and 5 bathrooms? how much money would that be worth? And so I'm picking a scenario, a certain type of house, and I'm putting it into my regression and getting a predicted value. So that's very common with like environmental policy. What would happen if we polluted this much in the future to, for example, sulfur in the air, which is a bad thing to have in the air. We could do scenarios, different scenarios. What if we regulate at different levels? What will happen to air quality? So that's a little bit different than forecasting because it's looking at specific scenarios for specific reasons. Add more cool charts is always another way to go. Adding cool charts is a great way to kind of show off your skills when you graduate with your degree. Employers love cool charts to show to clients. One of those that we've looked at is that butterfly chart. You could do that for your project. All right, so make sure to let me know if you have any questions about this. Good to talk to you guys, but I wish you could respond. I'll see you soon.